Hello everyone. Now we can solve some question which are based on Euler's theorem with 3 variables. So I have taken here one question. So question is given like in terms of u and 3 variables which are x, y, z. U is equal to sine inverse of this whole function which is in terms of x, y and z. We have to prove it. The question is show that x into del u by del x plus del u by del y plus del u by del z is equal plus tan y is equal to 0. So question से तो पता चल जाता है कि ये पूरा नॉन होमोजीनियस फंक्शन है. क्यों? क्योंकि यहाँ पे साइन इनवर्स के साथ ये पूरा आ चुका है. So we cannot say that it's a homogeneous function, but we can convert that into homogeneous function. How we can convert that? क्यों convert करना है homogeneous function? Because we have to apply Euler's theorem, और Euler's theorem हमें homogeneous function को apply करना है. तो first thing is we have to convert it into homogeneous function. And why we can convert it? Because part of this function is homogeneous. I will go to the next slide and here I can explain. So if you look here, this numerator is of order 1, and if you go look at this denominator, this will be of order 4. So if you look at this function which is in the square bracket, its order of -3. 1 minus 4 क्या हो जाएगा? -3. So its for order is -3. So ये फंक्शन जो स्क्वायर ब्रैकेट में दिया है वो होमोजेनियस फंक्शन है, क्योंकि सारे पावर ऑर्डर विल बी -3. लेकिन अगर हम इसके साथ साइन इनवर्स के साथ अगर पूरे फंक्शन को हम कंसिडर करते हैं तो नॉन होमोजेनियस फंक्शन होता है, क्योंकि हम x को वी कैन नॉट राइट इट इन दिस फॉर्मेट x रेज टू n इंटू एफ ऑफ y बाय x. इस फॉर्म में हम नहीं लिख सकते. क्यों नहीं लिख सकते? क्योंकि ये साइन इनवर्स अगर बीच में आ रहा है. इफ़ आई टेक आउट x कॉमन हियर, स्टिल आई कैनॉट टेक दैट कॉमन before sine inverse. I cannot do that. So because of that sine inverse, it's becoming non-homogeneous function. तो मुझे क्या करना होगा? ये sine inverse को किसी तरह से हटाना है वहाँ से. So what I will do it, I will move it, shift it to the left hand side. तो मैंने जी यहाँ पे किया हुआ है. Therefore I have shifted it to the left hand side. तो वो हो जाएगा sin u, क्योंकि ये यहाँ पे sin inverse है तो left hand side में shift करने के बाद वो आ गया sin u. So the pura function that came to as sin u is equal to whatever this function has been given. So now this complete function became a homogeneous function. We already see that this is of order -3. So now this became a function of homogeneous function. Now since function is homogeneous, we can apply Euler's theorem for it. Before I apply Euler's theorem, I will call this as a v, so that it will be clearly we can solve it. So that's what we have written. V is equal to sin u. I have considered it as equation 1, and as we consider this v is as equal to this given function. So if you look here, हमने लिखा है sin u, इसका this is equal to this one, and sin u is equal to v. That means this is equal to this one. It's something like this: a is equal to b and b is equal to c. That means a is equal to c. Sin u is equal to this one. V is equal to sin u means v is equal to x, this whole function, and I have written this here in the equation 2. V is equal to this whole function. Now what we can do it, we can differentiate this equation with respect to x, y and z, because that's what Euler's theorem says that. So that's the reason. Left hand side of the theorem, if you see that this is something like this. So the given function which we have converted like in terms of v, that we can differentiate with respect to x, y and z. So हमने इसको equation 1 जो लिखा था, v is equal to sin u. This is what something was our equation 1. So now in this previous equation, wherever I see here v, I can keep the value sin u. So now this equation became something like this. So I have kept sin u wherever the v was there. Now partial differentiation of sine u, I have to take it with respect to x, y and z respectively. So we know that sine u's partial differentiation, it will be exactly like a regular differentiation, which is like a cos u, and since we are differentiating with respect to x, this del u by del x will come over here. Same way here also with respect to y we are differentiating, so del u by del y will come here, here del u by del z, and right hand side will be as it is. So this is a simple thing, differentiation we have did it here. Now if you look at this here, everywhere if you see in each term we see that cos u is there, so easily we can take that common out and we will come to this one. After taking out common, we can shift it to the left right hand side, so it will become like a denominator. And sin u by cos v, this is nothing but our tan u, we can write it about this, and then I have shifted to the left hand side, so it became plus 3 tan u, which is nothing but equal to 0. So this is how we have come to the proof of that what we need to show for this question. I hope you understood here. We just applied Euler's theorem for 3 variables, which is applied for homogeneous function. So first thing jo hai, first step here, if the question is not given in the homogeneous format, we have to convert it into homogeneous format, find out what's its degree, then apply the right in the format of homogeneous function, how we represent it, then differentiate it, apply the Euler's theorem, then do the partial differentiation, substitute the value and simplify it. You will definitely get the answer. If you remember all these steps, it will be quite easy for you to simplify other questions also. Hope you understood these questions. Thanks.